Hello, my dear all students. How are you all? I hope all of you are doing well. This is our sixth week of this semester, and in this week, we are going to do some equations, which is matrix method and Gaussian elimination method. We solve some equations by using these two methods. Now, let's start. For matrix method, you have to give some equations like 2, 3, or 4 equations, and you have to solve these equations. That means you have to solve the variable which are x, y, z for this equation, and you have to find out the value of x, y, and z by using matrix method. So let's start, and at first by using matrix method, we can simplify these equations by the following way. Like we have to find out the constant value of each variable, which is for first equation x equals to 1, y equals to -3, and z equals to 2. How we get this? This is the constant value of x, y, and z. Okay, and by this way we can find out uh, x, y, and z's values for each equation and written in this format, which is one matrix dot another matrix, which is the which contains x, y, and z in the column format equals to the constant value of the equation. And if we consider first matrix equals to A, second matrix equals to B, and third matrix equals to capital letter X, then we can write AX equals to B. AX equals to B. Okay. Okay, now let's move. And then we have to find out the value of capital letter X. So if we change the side, we get the capital letter X equals to a to the power -1 into B. We already know the value of B, but we don't know what's the value of a to the power -1. So our task is to find out the value of a to the power -1. Okay. Now, we already know what's the value of A matrix. So we can simplify this, and we can get the value of A equals to 2, which is a non-zero value. That means it's a non-singular value. That means we can easily get the value of a to the power -1. For finding the value of a to the power -1, we have to do some task like each and every column of this each and every column's value of this matrix. For this, at first we consider constant or a variable which is capital letter C, and capital letter C is using to find out the value of A, which is called the cofactor of A. So what's the value of C11? That means C11 means the first one means the row number and the second one means column number. That means C11, which is the position of the matrix value. And that means first upper left corner 1. When we find out these positions values, we consider the rest other values and get 1. In this way, we find out all the positions values. That means C12, C13, C21, C23, C22, then C31, 32, 33. In this way, we can find all the values. That means cofactor of A matrix, and we can write the matrix in the same way. And if we when we write this matrix, that means a cofactor of A, we just write the transpose sign on that matrix. And if we transpose this matrix, we get uh, the last answer. That means how we get this, we just interchange the row and column. Simply we interchange row and column, we can get the transpose matrix. Now we have to find out a to the power minus 1. We already get the a to the power minus 1's value, and if we uh, if we put the value of a 1 by a matrix into adjacent of A, we already got all the values of this equation, and we find out actually for a to the power minus 1. And finally, what's our equation? Our equation is x equals to a to the power minus 1 dot b. Uh, in this equation, we know all the values. That means a to the power minus 1 dot b, and we can find out the value of x. We just simplify each row and column, and we get this one, where from where we can say that x equals to half, y equals to 7 by 2, and z equals to 13 by 2. This is our desired equation, or this is our desired result. And this is the way by which we can simplify some equations by using matrix method. Okay, now let's start another method, which is Gaussian elimination method. Okay, now at first, what is Gaussian elimination method? Gaussian elimination method is also known as a row reduction method. What is called row reduction method? There are three types of row elimination method. One is swapping two arrows, then multiplying a row by a non-zero number, and final one is adding or subtracting one row to another row. Well, now the working procedure is given here. At first, you have to convert the system of equation into matrix form, then form argumented matrix, which is A such that B, and third one is by using row operation, transform the argumented matrix into an upper triangular matrix or row equivalent form. Upper triangular matrix or row equivalent form. What is this? We can see this in our next slides. Okay, now what is row equivalent form or upper triangular matrix? That means in upper triangular matrix or row equivalent form, all the triangular value must be 0 and rest others must be filled up with 0. Sorry, all triangular value must be 1 and rest other values must be 0. Okay, now we can solve some equations by using Gaussian elimination method. Here a question given for you where you can see that some equations, that means three equations are given here, and you have to solve this by Gaussian elimination method. For solving this, we write the equation in the following format, that is Ax equals to b, which we already know in matrix from matrix method, and we know what's the value of A, then X, then B. And now we write the equation in this format, that is argumented matrix, which is A such that B. Now we can see that what is the value of A such that B. We already know what's the value of A and what's the value of B. We just write in side by side, and we solve this equation. This is because we need to do this. We need to shape this equation as a equivalent row equivalent form. What's our task? Our task is that all the diagonal value must be 1 and the rest others must be 0. For this purpose, we have to do some task like we have to work on each and every rows. For this task, we need some calculation which I written here on the right side. I hope all of you can understand this. You know. uh, we finally get our row equivalent form, and from there you already see that all the diagonal value are ones and rest are others zeros and non-zero values. So row equivalent form have some other format which are you must have to uh, ensure that all the diagonal value must be 1 and the rest others must be 0, and there is some non-zero values combination. Okay, from this we can say that z last row contains the value of z, so z equals to 6. Second row contains the value of x, which is 3, and first row contains the value of x. But in the first row, uh, one diagonal value is 1, but the rest others are not 0. So we have to simplify this, and from first row we get x minus y plus z equals to 1. We can write this, and we already know what's the value of yz, and we can get finally x equals to minus 2. So our desired solution is x equals to minus 2, y equals to 3, and z equals to 6. Thank you all. Thank you for hearing my lectures. And if you face any difficulties or if you have any questions, please let me know through e-learning. Thank you all.